we're going to work on comparing fractions. That means telling which fractions are equal, which fractions are greater than, less than. All right, so you're going to need a few things. One is a piece of scratch paper. Another use is probably not yellow, it might just be a regular copy of these fraction strips. And then you should have the ones that, it might be in a little baggie, something like that, ones that are cut up. These are different colors, and everyone's they are not going to be the same color for the same fraction. The only reason they're different colors is just so they're easier while you're working on them to find what you're looking for. All right, so on your scratch paper, you're going to try to be careful to not write all over it. Okay, so don't write all over it when we do one problem, like we're going to draw a number line. Don't write it all through the paper. Try to use just the top part of it. I'm going to be using the whiteboard, so make sure that you have everything down before I erase that. All right, so the first thing we're going to start with is a number line. Just draw a line with arrows. Okay? Now, we've always used number lines where there's a lot of dashes on there or hash marks, and they'll count up whole numbers. 1, 2, 3, 4, 5, 6, things like that. All right? Well, we're only going to count to 1 on ours. So right here, make a hash mark and put 0. On this end, put 1. And then in the middle, you're going to put half. Okay? So what we're going to do right now, we're going to do about 3 different things in this video. So what we're doing right now is called benchmark fractions. If you want to write that on the top, you can. It's the word bench and then the word mark. Okay? These are benchmark fractions. Benchmarks are kind of like stopping points. In this case, it's almost estimating. We want to know, is a fraction closer to 0, to 1/2, or to 1? But the fractions we're going to use do not necessarily have to have a 2 in the denominator. Okay? So if you need even more visual than that, I can't hold mine up here the whole time, but you can put it on your paper. You could use this fraction with 2 halves. Okay, because this over here would be 0 for you. This would be 1, and this mark would be 1/2. And that might be helpful for you to see it, whether or not you use it on the paper or you just use the strip. Okay, so we're going to look at fractions and tell what they're closest to. All right, so you're going to leave this up here just like this. Okay, our first fraction is going to be 2/5. All right, that does not have this denominator. So what you're going to have to do, I would personally make this 1/2 a little bit longer. Okay, something so you can see. Now we're going to split this number line into fifths. Okay, you can also look at your fraction strips. You can look at your fifths here, or just take out the fifths so you can look at it. Okay, so I'm going to show you on the number line, and then I'm going to show you how to kind of check it with these. Okay, so we know if it's 1, what's the fraction if the denominator is 5? When the numerator and denominator are equal, that's 1. So those are 5/5. Okay, so we're going to break this without doing anything to our 1/2. We're going to break this up into 5 sections. 1, 2, 3, 4, and that number 1 is 5. Okay, now just for you so you can see them, I'm going to circle my hash marks. You do not have to do that. Okay, I just want you to be able to see it. All right, what would this fraction be right here? This would be 1/5, 2/5, 3/5, 4/5, and 5/5. Okay, because 5 is an odd number, we can't split it in half evenly. It doesn't divide by 2 evenly. So none of our hash marks were right here on the half. Okay, so mark 2/5. Is 2/5 closer to 0, to 1/2, or to 1? Which one is it for sure not closest to? Which one is it furthest away from? From 1, I can see that I have to jump 1, 2, 3 to get over there. How many do I have to jump to get to 0? 1, 2, essentially, right? It's 2 away. Okay, how about to the half mark? It's not even 1. And to get to 3/5 is over on this other side of 1/2. So which fraction is it closest to? It's closest to 1/2. Okay, now look at your fraction strips. If you put them up to each other, they should all be the same length. You can see that. Which one is closest to right here? Well, sorry, right here in the middle, goes right here, 1/2. But 2/5, it's right here. Which one is it closest to? Is it closest to 0, my finger right here for 1/2, or all the way over here to 1? We know it can't be 1 because you have to pass 1/2 to get there. But 2/5 is closest to 1/2. Okay, these are benchmark fractions. That means it's going to help us kind of get an idea. What is it closest to? Think about when we rounded or estimated, just regular numbers, not fractions. When we would say like 57, what is that closest to? Is that closest to 50, to 55, or to 60? That's kind of what you're doing. And we just did like 50 or 60. What's it closest to? Say it out loud. 60. That's basically what we're doing. We're just giving ourselves an idea. Hey, where do these fractions kind of fall? Okay, so that was the 2/5. Now I'm going to erase. You're just going to draw another one underneath. What I would do from now on when you draw them, let me erase my 1/5 marks. You're going to draw it, and then whatever fraction we're going to work with, you're going to write it right here. So you should already have one for 2/5. Now underneath, draw another line, number line like this, and then we're going to write the fraction 3/6. Okay? So you can break it into 6 if you want. Look at that. I wrote 0. That's a 1. And we know with the denominator 6, this is going to be 6/6. Okay? So break it up. 1, 2, 3 is right on there. 4, 5, 6. Okay? So 3/6. Count them. 1/6, 2/6, 3/6, write it underneath, 4/6, 5/6, 6/6. What fraction is 3/6 closest to? Or what number, excuse me, 0, 1/2, or 1? It's closest to 1/2 because it is 1/2. They're equivalent, they're equal. Now I want you to use your fraction strips to prove that. So find the 6's. These are broken into 6. This is easier for you because you can just lay them flat on your desk and see. 1, 2, 3. That's equal to 1/2 right there. Right in the middle. Okay? And so I'm going to give you one. You're going to do it. You're going to pause the video, and then you are going to do it on your own. See which one you think it is, just to kind of see where we're at. And then you're going to check it. Okay, so draw your third number line. I'm going to give myself some tallies up here so I remember where we're at. All right, that looks kind of messy, doesn't it? That's 1/2. Okay, I want you to figure out 7/8. So you're going to break this into eighths. Okay, this is 0, so don't count that one. But this one will be 8/8. Okay? Break them into 8. And then I want you to circle what it's closest to, what 7/8 is closest to. 0, 1/2, or 1. And then I want you to get your fraction strips out and check it. All right, let's check it. I made hash marks, so I have 8 out of 8. 7/8 is right here, and I said that is closest to 1. Now, I want you to notice that it can be closest to something and still be past it. So had I said 5/8, that's right here, right? 1/8, 2/8, 3/8, 4/8, 5/8. It's closest to 1/2, even though that's going backwards. Okay, but 7/8 is closest to 1. When you check on your strips here, I hold them in the middle, but you shouldn't even be having to hold them because they should be laying down. Count up. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. What's that closest to? Your finger over here in the middle or the end? The end, it's closest to 1. And if I wanted to write a multiplication problem to get up to that 7/8 using 1/8, what would I write? Say it out loud and see if you have what I write. 7 times 1/8 equals 7/8. Okay? Very quickly, I want you to write an addition problem for that, adding up to 7/8. You can write the 1 plus 1 plus 1 plus 1, but that's kind of boring, I think. So make one yourself. I wrote this one. What did you write? I put 2/8 plus 4/8 plus 1/8 equals 7/8. 2 plus 4 is 6, plus 1 more is 7. All right? I want you to remember those because as we go on with multiplying and adding and subtracting, I want you to see that you've been doing it already. And it's pretty simple. All right. I want you to write your 4th number line. Okay? Write your 4th number line, and then you are going to check out the fraction 3/4. What do you think that's closest to? Okay, so fix your number line so it looks correct. Do 3/4. Check it with your fraction strips. All right, what did you say for 3/4? Is it closest to 0? No, you can see that it's quite far away from 0. And 1/2 comes before. Like if you were going along the number line, you'd hit 1/2 before you'd ever hit 3/4. Okay? It is how far away from 1/2? 1. How far away from 1? 1. So it's right in the middle. It's the equal distance between 1/2 and 1 full. So you can't really say which one it's closest to, but I do want you to see it on your fraction strips. Okay, it's right over here. It's right in the middle between 1/2 and 1. All right, let's try. We're gonna try 3 of them. Okay, so you're gonna draw 3 number lines, labeling them 0, 1/2, and 1. Do that quickly and then check back. All right, on your number lines, I want you to write these fractions beside them. I want you to do them. I want you to check them with your numbers or your fraction strips, and then I want you to check them with a neighbor and see if you circled the same benchmark fraction. So you're going to label where it is on the number line, where 2/10, 6/7, and 5/9 are. And then you're going to circle what it's closest to, 0, 1/2, or 1. Okay, if you're having trouble, like if you look at that and you're like, ooh, 10, sometimes for me, when I count them across, I get too many too close together and then I have to have some spread out. You could always use this. Even if you already wrote your number line, if it's way different, like if you need to make it longer, do it. If you need to make it shorter, do that. Put it up there and write it across. Okay, and then you can just mark where the hashes should be. So you're going to mark it out to be in tenths, in sevenths, in ninths. Label where 2/10, 6/7, 5/9 are, and then circle the benchmark fraction that it's closest to and check it with a partner. All right, let's check the first one. 2/10. Should look a lot like this. Here's my 2/10, and it's closest to 0. I can tell because I only have to count 1, 2 to get there. How far do I have to count to get to the half? 1, 2, 3. So it's closest to 0. You can check it with your strips. You can see right here, this is 2/10. Still closer to 0 than it is all the way to the half. Okay, how about the next one? 6/7. What did you say? What's it closest to? What's its benchmark fraction? 1. 6/7 is way over here, and it's closest to 1. Check it with your fraction strips. 1, 2, 3, 4. That gives me the half right there. 5, 6, all the way over here. I'm closest to the end right here, right? Further away from the half, so it's closest to 1. Good. How about 5/9? What did you say for that one? Is it closest to 0, 1/2, or 1? It's closest to half. Look how close it is right there. And when I look at it on my fraction strips, I can see right here that 1/2 comes right in the middle of it. 1, 2, 3, 4, 5. 5 is right here, but its box is right, it goes across the 1/2. It's closest to 1/2. Good. All right, so I want you to draw yourself a line now underneath all of those. We're going to be done with benchmark fractions, and we're going to look at at something called improper fractions. So after you draw your line, I want you to write the words improper. It's IM. That's the prefix on it. Proper means correct, normal, right, formal. IM means not. Improper. It's not proper fractions. Okay? Improper fractions are where the numerator has a larger number than the denominator. So I want you to write these fractions right here. Write 5/4, 3 halves or 2s, and let's do, well, we already did 4s. Let's do 9/7. Okay? These are improper because they are, the numerator is more than the denominator. Okay? We know that if the numerator and denominator are the same, that equals what? It equals 1. So what we're telling you right here is that we have more than 1. So 5/4, it would look like this. Find your 1/4 strips, and then this paper, find where you have 1/4. You have 1, 2, 3, 4, 5. You can even kind of, don't bend it too much, but just show that you have this one extra. Okay? So everything on this page equals 1. You see how my 1 strip is way at the top here? Okay? That equals 1. So this is showing you 5/4. I have 1. How many extra do I have? 1/4. That's what it actually equals. 5/4 equals 1 and 1/4 left over. Okay? So what you're doing with these smaller numbers, it's a little bit easier. When you get into larger numbers, sometimes it gets a little bit harder to see it so quickly. But I can say, hey, how many of these equal a whole? 1 whole. Well, 4 of them. Well, 4 like think of it almost like division. I had told you at one point that this fraction symbol can mean out of, it can also mean division. Watch this. Equals 1. We already know that. And how many were left over? 1/4. Okay, so I want you to write that, and I'm going to show you the division. Make a long division symbol like this. These are easy digits to work with. How many times can 4 go into 5? 1. Because I'm doing 5 divided by 4. 1 times 4 is 4. I subtract it. There's 1 left. Is there anything to bring down? I had to check that it was smaller than my divisor. Nothing to bring down. Then I have, that tells me my answer is 1. And what would we say? Don't write this yet. We'd say remainder 1. But when we're working with fractions, we have to write our remainder as a fraction. So we don't need the R. We just say there's 1 out of whatever our divisor is. How many were there? 1 out of 4. That's what that is. I'm figuring out how many whole numbers are in there. Okay? So let's try this next one. 3 2s. Use your fraction strips. Find the halves. All right. Use your strips right here. I have 1 half, 2 half, but I need a third. Okay? If you have it on your desk, you might be able to bend it back a little bit. I don't want them bent too much, but if we have to, we have to. That's how you have to work with them, okay? All right, so how many are there? There's 3 of them. How many whole do I have? I have 1 whole and 1 left over. So I have 1 whole, and how many 2s were left over? 1. 1 out of 2. That equals 1 1/2. Now let's do the division of it. 3 divided by 2. How many times can 2 go into 3? 1. 1 times 2 is 2. Subtract. Is that less than my divisor? Is there anything to bring down? No, so that's my remainder. Okay, but how do I have to write it? My remainder has to be written as a fraction. So I have 1 left, that's my numerator, out of, how many did I start with? 2. Out of 1/2. I want you to pause the video for just a minute, and I want you to try this one on your own. Use your fraction strips first to make 9/7 and see how many whole do you have. That's your whole number. And then what's your fraction that's left over? I want you to do that. I want you to write it here and try to do the division. I'm not going to do it, so you're going to just pause for a second, and then I am going to do it on here, and I want you to check your work with mine. Okay, so pause quickly, come back when you're done. All right, I hope you did it. All right, 9/7. Look at, your number or your fraction strips and your 7ths here. I know to have 1 whole, how many 7ths are there? 7. And I'm going to add 2 more. Okay, so I have how many whole bars do I have? 1. And how many are left over? 2 out of 7. 1 2/7. Okay, now do the division of it. 9, read it like this, 9 divided by 7, that'll help you. 9 divided by 7. How many times can 7 go into 9? 1 time. 1 times 7 is 7. How many are left over? 2. Is that smaller than my divisor? Yes. Is there anything to bring down? No. So how many are left over? 2 out of 7. These are the same answers. 1 2/7. Okay, so I showed you 2 ways to do it. Some of this, when they're small numbers like this, will be something most of you can do mentally. You'll look at it and say, well, how many times does 7 go in there? Oh, 1. 9 minus 7 is 2. There's 2 left out of 7. All right? So go down a little bit. I'm going to erase this. I'm going to give you some improper fractions, and you are going to fix them, okay? When we have, let's see, I don't know which one I just gave you. 3 out of 2, I think we used that one. When we fix them, we make them proper. If we have a whole number and a fraction, that's called a mixed number, okay? Improper fractions right here. Numerator is larger than the denominator. If you have a whole number and a fraction, that's a mixed number. All right, so I'm going to give you 3 improper fractions, and I want you to change them into mixed numbers. So you're going to tell me really what's the division of it, writing the remainder as a fraction. And I want you to check them with your fraction strips to be sure that you're correct. All right, so leave yourself some room. You're going to check it with your fraction strips and write that answer down. And then you're going to do the division of it right next to it to show that you know what we're doing. All right, so let's try 13/10. Okay, and do a bigger one, 17/12. Okay, and 11/8. Use your fraction strips and write what's the whole number and how many are left over right here, and then do the division problem. 13 divided by 10, 17 divided by 12, 11 divided by 8. All right, when you check back, I'll have all my answers up here, so we'll be checking our work. Okay, ask questions of the teacher in the room if you need them. Otherwise, work on that quickly and then come back to check. All right, let's check them. 13/10. So I know going across here, to make 1, I have 10/10. Then I'm just counting up to 13. So I know 10 of them makes 1. How many extras do I have? 1, that'd be 11, 12, 13. How many extras more than that? 1 whole do I have? 3. So my answer is 1 3/10. Now when I do the division, I can see 10 goes into 13 one time, and there's 3 left. 3 out of 10. 1 3/10. All right, let's do the 12s. There's 17 12s. So I know that if I'm making 1, whatever my denominator is, there's already that many there. So if my denominator is 2, there's 2. If my denominator is 7, there's 7. If my denominator is 12, there's 12. Okay, but I have to go up to 17. So I'm going to count how many extras do I need. So 12, 13, 14, 15, 16, 17. Okay, so how many extras did I put on there? Well, this is up to 17. There's 1, 2, 3, 4, 5 left over. So I made 1 whole and 5 out of 12 left over. So it's 1 5/12. Now when I divide it, I get the same thing. I ask myself, how many times does 12 go into 17? 1 time. And then when I subtract it, 17 minus 12, there's 5 left. So it's 1 5/12. All right, what about that last one? 11/8. Use my fraction strips. I know how many of them make up 1. 8, 9, 10, 11. Now I have 11 of them there. How many are left over? 3. So I know that my answer is 1 3/8. And when I divide to check it, 8 goes into 11 one time, and there's 3 out of 8 left over. All right? When you are working on these on your own, you don't have to do the division as long as you can do that in your head. I can look myself and do the mental math. I can say, oh, well, 8 into 11, or I know that 8 plus 8 is 16. Since this isn't 16, 8 can only go in there 1 time. Well, then 11 minus 8 is 3. There's 1 whole and there's 3 left over out of 8. All right, if you're able to do that mentally, you don't have to do this part. All right, okay, draw a line under that. We're going to do our very last part. Okay, so I want you to write comparing fractions. Now, we've talked about this a tiny little bit. Well, when you're comparing fractions, if you don't have your strips to look at, you are going to have to make sure that your fractions have the same denominator. So right under here, I want you to write this. We know this symbol means alligator's eating this side, so it's greater than, and it's than, T-H-A-N, N, and at the end. That's a comparing word. If you put an E there, that's a time order word. First we did benchmark fractions, then we did improper fractions. The opposite of greater than is less than, with a T-H-A-N, and equal. Okay, this is how we'll compare fractions. All right, now remember, look at this for just a minute. We've said this, and honestly, for some of us, this takes us a while to figure out. The larger that the denominator is, the smaller that your piece is. All right, so look at 12. That's a large number, but look how tiny that piece is compared to, let's say, a third. Third's way up here, okay? And if that's too far away for you, then take your 12 strip and move it up so you're right underneath each other. But 1/12, I can see it's only this much, a 1/3. So which one's larger, 1/12 or 1/3? 1/3. All right. But what if I said 5/12 and 1/3? Write that down. 5/12 and leave a space, and 1/3. Okay? You can take your 12 strip and put it right under the 1/3 so you can see it if you want to, or 5/12. 1, 2, 3, 4, 5. Look at the end line. I'm going to write on mine. 5/12 goes up to about here. Which one is bigger? 1/3, whose line is right here. This is 1/3, and this is 5/12. Which one is bigger? 5/12. Okay, so I want you to put the right symbol in.